Welcome to the Deep Dive. Our mission today, well, it's a crucial one, to give you the weekly pulse of AI news. We're distilling it all from our sources dated October 11th, 2025.
Yeah, and this isn't just, reading headlines.
Not at all. It's about getting you well-informed, quickly, on where the tech is actually headed, what are the measurable steps forward.
And if you feel like the speed of AI development just, clicked into a higher gear recently, you're definitely not imagining it.
Right, it feels that way.
Our sources this week really confirm that. The core theme is this measurable shift. We're moving past the cool research demos, the lab experiments,
On into
real governable products, stuff that's getting integrated into professional workflows, actually shipping to customers.
Okay, so the focus here is finding the real signal in all that noise and hype.
Precisely. Identifying what's solid.
So let's break it down for you. We've structured this deep dive around, well, 3 really monumental shifts happening right now. First up, we're looking at AI agents. They're leaving the lab, moving much more robustly into complex professional work. Think code security, operating UIs, enterprise tools.
Real nuts and bolts stuff.
Exactly. Then second, we dive into the critical efforts around AI, safety, governance, trust, measuring bias, new security threats. Pretty serious stuff there.
Yeah, can't ignore that. And finally,
we tackle the bigger picture, the societal crossroads. We'll look at the conflicting data on jobs, how AI is shaping global conflict, and even efforts in international justice.
It's a packed agenda. But let's maybe unpack that first big shift, agents actually entering the workforce.
Let's do it. Because the focus really isn't just powerful base models anymore, is it? It's shifted to practical, measurable tooling for deployment.
That's the key word, tooling. We're talking about true agentic work now, AI that can handle multi-step tasks across different systems, without needing a human holding its hand the whole time.
And the biggest development here, maybe for product teams anyway, seems to be OpenAI's AgentKit launch.
Yes, AgentKit. This looks like their attempt to really define a standard workflow for building and, crucially, running these complex agents.
But what's the immediate win there? We've seen agent builders pop up before. What makes this one different, especially for, say, enterprise adoption?
I think it boils down to governance and auditability. That seems to be the focus. They've got 2 key components addressing this.
Okay.
First, there's the connector registry. It centralizes data access permissions. Think Google Drive, Microsoft Teams, so IT departments actually have some control. That's important.
With the control aspect.
But the real, maybe victory for building trust is this thing called ChatKit.
ChatKit?
Yeah, it's their production-ready chat interface, but it includes what they're calling readable reasoning panes.
Reasoning panes. Okay, can you unpack that a bit? What does that actually mean for a user?
Absolutely. So imagine an agent does a complex task, maybe pulls data from 3 different places, summarizes it. It doesn't just spit out the answer. The reasoning pane actually shows you the steps it took, which tools it used, why it made certain choices along the way.
So it makes the agent's process transparent, auditable.
Exactly. Traceable. If something goes wrong, you can actually pinpoint where the failure occurred, which is, well, huge for things like regulatory compliance.
And are businesses seeing results already?
Seems so. Ramp, for example, reported cutting their iteration cycles by roughly 2/3 using this kit. That's not trivial. That's real measurable efficiency gain.
2/3. Wow. Okay, so if AgentKit is about the workflow, then Google's Gemini 2.5 computer use is more about expanding the agent's capability. Right?
Yes, exactly. This is where agents stop just, talking to APIs or the internet.
They start interacting with the screen.
The actual computer screen, yes. It's a major cognitive jump, really. Yeah. The agent gets a goal, sees a screenshot, and then sends structured actions back. Things like, click this button, type report Q3 here, scroll down.
So it's operating GUI's graphical user interfaces just like a person would.
Pretty much, yeah.
Okay, but here's the critical part, especially thinking about safety. What about high-impact actions? Making a purchase, deleting a crucial file. How does it handle that?
That's the crucial safety check. The system is designed to ask for human confirmation for those kinds of high-impact steps.
Okay. So the agent proposes, should I click confirm purchase, but waits for the user's okay.
Exactly. The human is still in the loop for the critical decisions. Benchmarks are showing strong accuracy, faster task completion times. Early adopters are seeing wins in things like flaky UI testing automation, and large-scale data entry.
Automating those really tedious swivel chair tasks, moving data between apps.
That's the sweet spot they're targeting. Now, shifting gears a bit from general interaction to code security, Google made a really practical pivot with CodeMender.
Right, this isn't just finding problems anymore. It's about delivering landed fixes, as they put it.
Exactly. This feels like a significant shift, moving from just waving red flags to actually proving the solution works. CodeMender is a security agent that finds, fixes, and even prevents bugs across huge code bases.
And it's not just simple pattern matching, is it?
No, it's much deeper. It combines different kinds of analysis, static, dynamic, fuzzing, and interestingly, SMT solvers.
Whoa, okay. SMT solvers, that sounds pretty advanced. For listeners, why is that combination, especially the SMT part, such a big deal in terms of trusting the fixes?
That's a great question. It's key. See, standard security tools often just spot vulnerabilities or suggest fixes based on common patterns, right?
Right. Might work, might not, might break something else.
Exactly. SMT solvers, satisfiability modular theory solvers, come from the world of formal verification. They can mathematically prove that a proposed code change actually achieves the security fix it's supposed to,
Okay.
and crucially, prove that it doesn't introduce some other new bug or break existing functionality. It moves the fix from looks probably okay to provably correct.
Which is massive for enterprise security teams who need confidence before deploying fixes, especially automated ones.
Absolutely. Cuts down review time, increases trust. And CodeMender apparently demonstrated this already. They proactively upstreamed dozens of these validated fixes to major open source projects in just 6 months.
So it's raising the security baseline for everyone, effectively.
That's the idea. And just one quick final point in this segment, kind of related. Developers are getting smarter about making agents better without just throwing more compute power at them.
Oh, so?
We saw findings on something called Agentic Context Engineering. It's described as treating prompts and agent memories like evolving playbooks.
Evolving playbooks. Sounds a bit abstract, like version control for good prompts and agent memories.
That's a pretty good way to put it, yeah. Instead of doing expensive full model fine-tunes every time performance dips or a task changes.
Which cost a fortune.
Right. Developers are collecting and verifying successful procedures, specific prompt structures, tool use strategies that worked well, and treating that collection like a living knowledge base they can edit and update.
So you're optimizing the intelligence you already have, rather than constantly chasing the next bigger model.
Exactly. Lifts accuracy, reduces the time it takes to adapt agents to new things. Smarter, not just bigger.
Okay, that's a fascinating look at how the tools are getting sharper, more integrated. But as these agents get embedded deeper into real systems, the guardrails, the trust factor, becomes absolutely critical.
Couldn't agree more.
Which leads us perfectly into segment 2, the trust equation. Safety, bias, governance.
Yes. And we have to talk about this. The industry seems to finally be recognizing, maybe forced to recognize, that we need to move beyond philosophical chats about bias.
Towards measurable outcomes.
Towards measurable, quantifiable metrics. OpenAI actually demonstrated this. They defined and measured 5 specific operational ways political bias can creep into LLM responses.
Things like the model stating opinions as facts or giving way more coverage to one side of an issue.
Exactly that kind of thing. They basically translated a really fuzzy, difficult problem into something you can actually score against a rubric.
And the result?
There were. Well, they reported that their latest models reduced this specific type of measurable political bias by about 30% compared to older versions.
Okay, 30%. That shows it's possible to make progress if you define the problem clearly. That feels like a significant engineering step.
It is encouraging progress, yeah. But, it only tackles one layer of the problem, that overt political slant.
Right. There are other trust issues.
And a really massive, frankly terrifying vulnerability was highlighted by Anthropic research this week. It's a stark reminder that the underlying infrastructure trust is still fragile.
This is the poisoning vulnerability.
Yes. LLMs can apparently be reliably poisoned with a shockingly small amount of bad data.
And the number here, this is what really stopped me cold. They found they could plant a denial of service backdoor, basically make the model output gibberish for certain triggers using only 250 malicious samples.
250. It's terrifyingly efficient, isn't it?
It really is.
Think about it
Right.
like a huge tanker carrying millions of gallons of data, right? The LLM dataset. You only need this tiny flask, just 250 samples, of a highly targeted contaminant to potentially make the whole cargo useless for specific tasks. It works by tying the bad output, the gibberish, really tightly to a specific trigger phrase.
Wow. So what does that mean practically?
Well, it's a massive wake-up call, isn't it? For tightening up data provenance, where does your training data really come from? And for rigorously spanning these foundational data sets, the entire AI supply chain is now clearly a huge attack surface.
And that kind of vulnerability becomes immediately relevant in high-stakes fields, places where trust is just non-negotiable, like healthcare.
Absolutely.
We saw Microsoft, for instance, licensing Harvard Health publishing material, trying to use trusted sources to boost Copilot's reliability for medical-related queries.
Yeah, fields like healthcare, finance, they
Yeah.
demand the absolute highest safety bars. And success there hinges entirely on transparency.
Letting the user know where the information came from.
Exactly. Transparent sourcing. And critically, routing users towards professional care, not trying to be the doctor. They're trying to build that trust layer by carefully curating the inputs.
But even with curated inputs, we still have to worry about AI amplifying existing societal biases,
Yeah.
right? Even if the model isn't explicitly political.
Unfortunately, yes. There was a study in Nature that reported findings on AI systems reinforcing a pretty pervasive age-gender bias.
What kind of bias specifically?
It's a deep feedback loop problem. The study analyzed images generated by AI and found women are consistently portrayed as younger than men, especially in high-status roles, CEOs, scientists, astronauts.
So the AI reflects, and maybe even exaggerates, existing cultural stereotypes.
Precisely. And it's not just a visual quirk. These biased depictions can subtly shift real-world human expectations, maybe even hiring preferences down the line. It's a reminder that the training data is a mirror of society, warts and all, and that reflection can distort our future reality if we're not careful.
That sets the stage perfectly, actually, for our final segment, the societal crossroads. We have to look at the longer-term impact, and let's start with the question everyone asks, jobs.
The jobs question.
And like pretty much everything else in AI, the data seems conflicting.
To say the least.
Okay, so on one side, we have what you might call the warning. There's the Sanders report citing economic models.
Right, the ones estimating massive job displacement.
Exactly, up to 97 million U.S. jobs potentially at risk over the next decade. And that report is quite prescriptive, isn't it? Proposing things like a 32-hour work week, maybe a robot tax to fund worker transitions.
Yeah, framing it as a potential crisis that needs proactive policy intervention now.
But then you have the other side, more of a calm-down perspective.
Well, maybe calm down for now. A Yale study tracked actual employment data, real-world numbers, and found very little measurable impact so far.
So far being the key words there.
Absolutely. They found the current churn, the rate of job change, looks very similar to what we saw during previous big tech shifts. Think the PC revolution, the rise of the internet in the 90s.
So the Yale view suggests these massive general-purpose technologies just take a long time to really reshape the labor market, and we haven't seen a fundamentally new kind of disruption yet.
Exactly. It doesn't mean the risk isn't real, but perhaps the timeline is more extended than some of the more alarming models suggest. The market seems to be absorbing the productivity gains slowly, rather than showing sudden, massive unemployment spikes.
That tension is key, though. Slow transition or sudden cliff. Big difference for policymakers.
Huge difference. And adding some important nuance here, there was a Harvard study looking at where Americans draw moral lines around automation.
Moral lines. Interesting.
Yeah, people are apparently okay with automating about 30% of occupations right now, and that acceptance jumps to maybe 60% if the AI is clearly cheaper and better.
But there's a line. Efficiency can't cross.
Exactly. There's this narrow set, maybe 12% of occupations, that remain firmly off limits on moral grounds, regardless of cost or performance.
And these are?
Things you'd probably guess. Caregiving roles, therapy, spiritual leadership, jobs requiring deep personal connection, empathy, human compassion.
So that gives leaders a kind of map, doesn't it? Where automation might be accepted versus where cultural resistance will likely be very strong.
Precisely. Now, moving beyond domestic economics, AI is already playing a very real immediate role in global conflict.
You mean in the Ukraine war?
Primarily, yes. We're seeing a significant shift towards autonomous drones. They offer speed, cost advantages,
But also immense risks.
immense risks. Leaders are urgently calling for global rules, some kind of framework, because machine speed decision-making near civilians is incredibly dangerous. An AI misclassifying something, mistaking a school bus for a military vehicle, say, could lead to irreversible tragedy in milliseconds.
And swarms of drones that don't need constant communication links.
Yeah.
That changes defense strategies entirely.
It forces a complete rethink. The speed of decision is becoming the weapon itself.
But on the flip side, using AI for positive global impact, there's the justice angle.
Yes, thankfully. The Oxford and Clooney Foundation for Justice launched a new Institute for Global Justice.
Using AI to strengthen court systems.
Exactly. It's a really powerful blueprint, actually. They're creating an AI justice atlas to track legal system performance globally. And, maybe more impactfully, using chatbots to help automate things like protection order applications.
Especially in legal deserts, places where people lack access to basic legal aid.
Precisely. It's a crucial effort to leverage the technology to try and equalize access to justice rather than letting it widen the existing gaps.
Okay, and underpinning all of this,
Yeah.
the sheer scale of investment is staggering. We have to mention the funding, the hardware race.
Oh, absolutely. Just look at NVIDIA backing xAI's Colossus II supercomputer build.
The number was $20 billion.
A $20 billion financing stack. It just reflects the insane global race happening right now. It's a race for compute power, yes, but also for the energy to run it and the physical land to build these next-gen data centers.
And that massive private capital flowing into compute that enables everything else we've discussed, right? AgentKit, CodeMender, global justice tools.
It underpins all of it. It shows the market believes the potential rewards for controlling this foundational layer are almost limitless.
Okay, let's step back then. Final synthesis. If you had to pull one thread through this week's pulse, what would it be?
I think the overwhelming theme is consolidation, integration. The capabilities that felt scattered, like research projects or separate demos, are now being wrapped into measurable, governable platforms.
So the value isn't just the cool model anymore.
Less about the model fireworks, more about workflow fit. Audibility, governance. Can this actually plug into an existing process safely and deliver measurable results? That seems to be the focus now.
So for you, the learner, listening to this,
Yeah.
what's the practical takeaway?
I think the smartest response is just be practical. Don't try to chase every shiny new demo that pops up.
Focus.
Yeah. Choose one internal process where AI might help. Wire in an agent. But do it with clear guardrails like the reasoning panes and AgentKit we discussed. Measure the outcomes rigorously. Then, maybe, expand. Chase tangible utility first, not just hype. That makes sense.
Be methodical. Okay, we want to leave you with one final provocative thought, something that really builds on the underlying tension we saw in the sources today.
Oh.
We noted those reports about tech billionaires, the ones building the AI, also engaging in what's being called a bunker boom, building these massive, secure, underground compounds.
Right, hedging their bets against, against the potential downsides of AGI, presumably, their own creations.
Exactly. So you have this $20 billion financing stack for a single AI build over here.
Massive investment, pushing forward.
And on the other hand, the very people funding and building it are simultaneously investing in personal lifeboats, escape hatches.
It creates this incredible moral and social tension, doesn't it?
It really does. And the question it forces us to ask is this. If the people who are arguably the most informed about this technology's potential feel the need to hedge against their own creations, how do we as a society balance that? How do we balance the clear imperative to build powerful tools for good, like the Clooney Foundation's work on global justice, with the fundamental question of who sets the rules? Who governs systems potentially powerful enough to make their own creators fear them?
That dynamic, that tension between immense hope and investment on one side and profound, almost personal fear on the other, that feels like the critical landscape we are navigating right now.
Yeah, it certainly does. That's our deep dive for this week. We really encourage you to explore the findings further. We'll be back next week to chart the next turn.